Hello, y'all. This is Mr. Spengler. Hopefully, this finds you healthy and happy. Um, I just want to say a few things before we get started. It's probably going to be handy to have Amplify up right now, along with this video. And then there's an online worksheet. If you follow along, there's going to be answers in this that'll be easy for you to answer if you're following along. Blue, time to go lay down. My dog says hello. Baloo says hello. She's a good girl, but she gets excited when she sees squirrels. My apologies. Anyway, this coronavirus map is today. This is Wednesday, May 6th. And if you notice, if you look, does it look like we're having fewer cases in Minnesota? The answer is completely no. So a lot of us, we're getting buggy because we've been on lockdown for so long. But you know what? In Minnesota, the cases are going up. You might say, oh, that's not really where we are. Well, I beg to differ. If you notice, right here, Stearns County, Minnesota, our county, it only takes 3 days for the number of cases to double. A few days ago, it was 1.5, so it's getting better. Part of that's because we're testing more and we're seeing more because we're able to see more, but there's a lot of it happening, and it's happening in our area. So it's moved from the Twin Cities area up to us and other areas as well. But it's getting into rural Minnesota. So now is when you wanna not let your guard down. Social distancing is more important right now than ever before. We've got a number of families that are being hit by this in our district. So just assume if you're near somebody, they've got it, and have a mask on and take care of yourself. And here's the telling part. So in Hennepin, that's the home to Minneapolis, they had a big surge early on. This is in probably March. Okay, if you look at Stearns, we're having a huge surge right here, and it's in May. So it's taken a while for it to get into the rural areas, and it's here. So just be aware of that. Don't let your guard down. Stay healthy. By all means, get outside, but distance yourself. Enough of that. Okay, yesterday we started with this, and this is the water cycle. You were supposed to share some thoughts. Hopefully, you might have said that, hey, the water cycle is driven by energy from the sun as well as gravity. Those are the two forces that cause it to happen. The energy from the sun heats up liquid water, that liquid or ice. The ice would become liquid. The liquid then can evaporate. And evaporate means to go from a liquid form to a gaseous form, water vapor. Okay? And water vapor is invisible. When it starts to get condensed, then so this arrow represents condensation. It could be happening over here too. There's nothing special about this, but if it goes over the land and condenses, it'll form a cloud. And if there's enough of those little tiny water droplets to run into each other, they become too heavy to be held up by the upwelling air in this area, and it'll start to fall as rain. That rain can join together and run down. That's called surface runoff. If it piles up in a low spot and forms a lake, that would be surface water, or a river is surface water for that matter. If it seeps into the ground, then it's called groundwater. And it's really important to life on Earth, as well as our weather. All right. Um, so next. Um, Galetown is a city that's experiencing increased rains, more severe rainstorms. So there's three claims as to why that's happening. One is it's because a reservoir was built nearby, creating a lake, kind of like the chain of lakes here in Cold Spring, and that's the cause of the severe rainstorms. Claim two is, hey, warmer weather is causing it. Claim three is, hey, there's stronger winds, and those are causing the rainstorms. So those are the three possibilities. So you were supposed to go to the sim and do a little experimentation. So right now I've got it set up, and I'll just go ahead and run it and explain how I have it set up. I have it set up so it's medium sunshine. We're going to keep that the same, but I have the biggest lake I can. That's 5 out of 5 on the lake, and we're looking for the biggest number here, and it's 44 kilograms. So I'm writing down 44 kilograms, and that's if we have a big lake. Okay, and if I go up to analyze, just to show you this. This is kind of cool. I like to back this up and show what's going on. Okay, so um, at this point, you got uh, the temperature is rising. See how it's rising in that parcel? So that box is a parcel. It's just a chunk of air that behaves as one unit. So it gets to a certain temperature, 30 degrees Celsius, and it's less dense than the surrounding air, so it starts to rise like a hot air balloon. And when it rises, it gives its energy to the surrounding, because notice it's 15 degrees Celsius here, but the surrounding air is only 0. So it's losing it, and since it's getting cool, it's below the dew point, the temperature at which the air can't hold any more water, so water vapor is coming out, and that's called condensation. So you've got this big cloud forming, and you get to a certain size, and then it starts to rain. Okay, so remember, we got 44 kilograms of moisture into the air by that. Now I'm going to change the settings and make the reservoir much smaller, just to a 1. Everything else is going to stay the same. I hit run, and we'll watch and see what the biggest number is here. Okay, so it's heated up. So 17 kilograms. Okay, and much the same, I could analyze it, but we don't have time for that, so we're going to move on to the next step. The next step is here, right here. So if you didn't fill this out, now's a good time. The surface level for test 1 was 5, and the water vapor I said was 44. Test 2, it was 1 and 17. So what's the relationship? Okay, as the level of surface water increased, the amount of water vapor increased. Make sure to write that down. And here we go to the next part. We use some words. Evaporation is the process by which liquid changes into gas. Liquid water turns into a vapor, water vapor. Water vapor is water as a gas. These are not complex terms. They're terms hopefully you've seen before. And condensation is the toughest part of the water cycle for kids to remember. That's where gaseous water becomes liquid water. It's like the sweat on the outside of a Coca-Cola can in the summer. Make sure to hit hand in when you're done with that. Okay, then on to the homework. Okay, on to the homework. Here we go. It says, in which of these images is water present? Water is present here as liquid. In the living stuff, there's water there and there and there. There's water you can't see in the air here, and then there is water, liquid water up in those clouds. Here, there's water in the plants. There's water in the clouds. There's water in the air, not a whole lot, but there's also water in the soil. Okay, and here, there's water in the snow, in the plants. Underneath the snow, there's probably frozen water. So in all these places, you would find water in the air, in the lake, in the clouds, in the snow, and in the living things. The place where there's probably the most water, I would guess, is A first, then C, then B. So what do? A is you go A, C, B. Just move that down there. Save and continue. And then the second part, condensation. Where is condensation? Check your answers. Condensation goes here. Evaporation goes here. Condensed liquid water goes here. And rain goes there. All right. Now what's running this? Sunlight energy as well as gravity. All right. Make sure to hand that in. And then we're going to move on to today's topic. And today's topic is the atmosphere. And I gotta find, don't seize up on me. So we're going to talk about the atmosphere today. And the atmosphere is exceptionally important. If you remember, there's various spheres that we've been studying in earth science. There's the lithosphere, which is the solid part, or geosphere. There's the hydrosphere, which is the liquid part. and now we're hitting the atmosphere. And we've also kind of touched upon the biosphere, the living part. But right now, today, we're focusing on the atmosphere. And the atmosphere, if you take a look right here, you see how skinny that is? It's not as big and endless as we think. It's really a thin skin on the top of our planet, but it's so important. It provides air for us to breathe. It protects us from objects that are flying around in space. It protects us from harmful radiation like UV and X-ray radiation that gets absorbed before it hits us, and it also keeps us warm. So it's really, really important to our existence. So has the atmosphere been the same throughout Earth's history? And the answer is no. When Earth first formed, remember, it was a molten ball, kind of like a fiery Earth, Hadean. It was largely hydrogen and helium was present, and ammonia and methane. Okay, we're talking about the gases. Now here, water vapor started forming, and it was so hot that liquid water couldn't exist. So the water that was here was as a vapor. Okay, then carbon dioxide started to rise, largely due to volcanoes or volcanic action and things like that. But if you notice, nitrogen has been for a long time a major component of our atmosphere. Okay, and today, if you notice, nitrogen is the majority, and then oxygen is the second most prominent gas. And a lot of times people don't think that, but oxygen is roughly 21% of our atmosphere, and that's really important. So why has it changed? Why has the atmosphere changed? Well, there were chemical reactions happening during volcanism. As things cooled down, as things ran into other things, we had chemical reactions happening, and those chemical reactions changed the makeup of the atmosphere. Living chemistry. There were critters that lived off of, let's say, methane and ammonia. They could live off of that, and they would change it from one substance to another. And then finally, cyanobacteria evolved, and they started doing photosynthesis, and they changed it so oxygen started showing up. So right around here, 2 billion years ago, oxygen started showing up, and that changed things dramatically and actually killed off a lot of different critters. All right. Today, the composition of our atmosphere looks like this, where nearly 80% of every breath you take is nitrogen. It does us no good or no harm. And then oxygen is roughly 21%. And all the other gases, most importantly, argon and carbon dioxide, this number has changed. So when this was made, it was 0.036. It is now 0.044, which is a considerable change because this has happened during the time I've been teaching. Okay, so it goes nitrogen, oxygen, argon, carbon dioxide. And carbon dioxide is higher than ever before. Moving on. So if we have a certain amount of oxygen in the air and I'm breathing it, why aren't we running out? And I bet a lot of you were thinking of that. Well, it turns out there's something called the carbon dioxide oxygen cycle. And it's basically, there's a balance between photosynthesis, what plants do, and respiration, what all living things do, to burn the food and release the energy. So during photosynthesis, what plants are doing in cyanobacteria, they're taking carbon dioxide and combining it with water to make sugar, and a byproduct is oxygen. So they're producing oxygen, and then we come along and breathe that oxygen. Respiration is what we're doing. We take the food, glucose and oxygen, and we burn it. We breathe out carbon dioxide and some water. Okay, so in nature, these are in balance. So there's no real problem. But we've kind of messed that up as human beings because we're burning a lot of fossils now. So that is changing. But that's important that you realize these two processes are exact opposite of each other, and they're in balance. Finally, we have the nitrogen cycle, and it's pretty complex, but just realize we can't use nitrogen in the air, but we need nitrogen. We need nitrogen because it's in proteins, it's in the DNA that you learned about last year. What has to happen is bacteria or industrially, it has to be fixed as a nitrate and be in the soil. Plants will absorb it. We eat the plants. The plant and animals leave waste behind and give it back to the soil. But that's it in a nutshell. And that's it for today. Thank you, and have a great day.